Hello learners, once again, my name is Mr. Poch Lola. Welcome to the topic experimental techniques. We continue looking at testing for ions. So far we've looked at how you can test a solution for the presence of cations, which are the positively charged ions, using two procedures, namely using sodium hydroxide, aqueous sodium hydroxide, and using aqueous ammonia. For the two tests, the results are different or sometimes similar. So in this case, you need to know exactly what each test produces, and you look out for the formation of precipitates, and the formation of such precipitates is accompanied by color change. So you note down the color of the precipitate when only 3 drops are added to the sample, and you note down the color change when extra solution is added. Very important. All right, so welcome to how you can detect the presence of anions. And remember that anions are negative charges or negative ions. These are negative ions. They're negative ions. Okay, and the word anion comes from anode ions. Anode ions, named after the electrode to which the ion migrates to during electrolysis. Okay, so instead of saying anode ions, simply take the first part, the AN, and then you add the ions, so you have anions. Okay, very important. That's just by the way. All right, so these ions are commonly tested. The commonly tested anions at this level, at Msce level, are sulfates, halides, and nitrates. Okay, sulfates are basically SO42 minus. All right, let me scribble this somewhere down here. So we say a sulfate is SO42 minus. It's found in solutions such as magnesium sulfate, potassium sulfate, and other sulfates. And then you have halides. Halides are also called the group 7 group 7 elements, which are salt makers. For example, fluoride ions, chloride ions, bromide ions, and the iodide ions. Please take note of how we are naming them. We are saying fluoride, chloride, bromide, and iodide. Not fluorine, chlorine, bromine, iodine, no. Their ions are named by simply adding IDE at the end. Fluoride, written like this. Fluoride. Okay, chloride ions. So there's IDE at the end. Bromide ions. Okay, all right, so I'll take you through the procedure, the outline of the procedure of how you can detect the presence of these ions in solutions. All right, so how would you tell that a given solution contains sulfate ions? All right. So to detect the presence of sulfate ions, all you have to do is simply add a few drops of dilute hydrochloric acid to the sample, followed by a few drops of barium chloride solution. The result is the formation of a white precipitate. If the sulfate ion is present in the solution, then a white precipitate is going to be formed. Take note that here we are using two test solutions. Let's say that the substance you are testing is substance X. So to this you add hydrochloric acid, which is aqueous or dilute, followed by barium chloride. Barium chloride is BaCl2, also aqueous. The result, if the sulfate ions are present in the solution in X, then you are going to have a white color. I mean a white precipitate. In other words, white solid is going to be formed. This is the confirmatory test to show that sulfate ion is present. Please take note. So we are saying that in order to tell that sulfate ions are present in a solution, you simply add the solution to the solution you suspect to contain sulfate ions. You add what? You add hydrochloric acid, and followed by a few drops of barium chloride, and if the sulfate ions are present, you are going to see the formation of a white precipitate. Now remember that a precipitate is just a solid product. Okay? All right, so that's how you test for sulfate ions. If you have questions regarding this, don't hesitate to let me know in the comment section. All right, so how do you tell that a given solution contains halide ions? Remember halide ions from the word halogen, from the term halogens. Remember halogens are the group 7 elements. So their ions are called halides. All right, example is fluoride ion. We write F to the -1, and then chloride ions, Cl to the minus, then bromide ion, Br to the minus, and the iodide ion. These are found in substances such as sodium fluoride, for example. So this part is a halide. Okay, sodium chloride, which is common salt, also contains a halide which is called chloride ion, and so on. So in order to tell that these are present, or any one of them is present in a solution, all right, you simply add, the procedure is simple, add a few drops of dilute nitric acid. Take note, here you add nitric acid. Nitric acid is HNO3. That's the chemical formula for nitric acid, but it has to be dilute, meaning it is supposed to be in solution form in which water is added. Then you add, after you have added nitric acid, then you add a few drops of dilute silver nitrate solution. Silver nitrate is AgNO3. Okay, but it has to be also in aqueous solution, in a waterless solution, okay, dissolved in water, or like diluted with water. Then you observe and record the color of any precipitate that is formed. Okay, so take note, upon adding nitric acid followed by silver nitrate. If there is no precipitate formed, then that should be fluoride ions. So fluoride ions do not form any precipitate when dilute nitric acid and silver nitrate are added, there is no precipitate formed. But if they are chloride ions, you'd be able to confirm that chloride ions are present by the formation of white precipitate. So a white precipitate indicates the presence of chloride ions. However, if it is bromide ions present, then you look for a yellow precipitate. So a yellow precipitate is an indication that the solution contains bromide ions. If also notice that this is pale, meaning a faint yellow precipitate. All right. If the solution contains iodide ions, then you do tell the presence of iodide ions by simply looking out for yellow precipitate. So the formation of a yellow precipitate is an indicator that iodide ions are present. All right, so this is how you would tell the presence of these halides in a given solution. All right, what about if we are interested in detecting the presence of nitrate ion? I mentioned that a nitrate ion is NO3-. All right, so in order to tell the presence of a nitrate ion, all you have to do is first of all, take a solution, a little nitrate solution, then you add to a little nitrate solution, add aqueous sodium hydroxide. Then you add or you drop a small aluminium foil into the solution and warm gently. All right, so this procedure is a bit involving. So we are saying first of all, the nitrate ions should be reduced to ammonia. So the procedure involves adding to a little nitrate solution, the solution that contains nitrate, let's say X. You add sodium hydroxide solution to it, and then you add the aluminium metal or foil to the solution, and then heat it. If the ions are present, nitrate ions are present, ammonia gas is given off. Okay, so this is going to lead to the formation of ammonia in gas form. How you can confirm that the gas formed is ammonia is by simply dipping what is called the damp red litmus paper. It is going to make red litmus paper turn to blue. Okay, this shows that ammonia is formed, is a base. Okay, remember that a base will change red litmus paper to blue. Very important. So once again, the procedure is a simple one. Of course, it involves a series of steps. So one, You take the solution that you suspect to contain nitrate ion, then add sodium hydroxide to it. Then you get a piece of aluminium foil into the solution and heat it. So the product is going to be ammonia gas. But how do you confirm that the gas formed is ammonia? By simply dipping in a red litmus paper. If the red litmus paper turns blue, then that shows that the original substance is one that contains a nitrate ion. If the color change, if the litmus paper doesn't change color, it means the gas is something else, and therefore you conclude that the solution, the original solution, was not or did not contain nitrate ion. All right, so I would like to leave you now. Next time we meet, we'll be looking at testing for gases, and then testing for ammonia, and testing for other gases, including testing for water. That's what we're going to look up at next. My name is Mr. Pochilola once again. Wishing you the best. Please come back to this channel to learn more. Also inform your friends that it is possible to learn on this channel for free. So once again, consider to subscribe to the channel so that every time a lesson is uploaded, you don't miss anything.